this is a heat transfer in a post convection apparatus. Consists of main switch, voltmeter, temperature indicator, selector switch, this is a ammeter, and this is a dimmer. So this is a blower and manometer. So it has some specifications. That is a specimen is a copper tube, and the size of the specimen is inner dia is 25 mm and 400 mm long. Heater is externally heated and nichrome wire band heater. Ammeter is a digital type, that is 0 to 20 amps AC. Voltmeter is a digital type, that is 0 to 300 volt AC. Dimmer for a heating coil is 0 to 230 volt and 2 amps. Thermocouple used is a 7. So centrifugal blower is used, that is single phase 230 volt, 50 hertz and 13,000 RPM. Manometer is a U-tube with a mercury as a working fluid, and orifice diameter is that is D0 is 20 mm, and GI pipe diameter, that is DP, is 40 mm. T1 is a air inlet temperature, T2 is a T2 to T6, T2, T3, T4, T5, T6 are the specimen temperatures, and T7 is air outlet temperature, and TR is a room temperature. This is about the specification. And coming to this, first one is a orifice brass of a diameter, that is 20 mm, and thickness is 3 mm. Second one is a 40 mm gate wall. This is a gate wall of 40 mm. Third one is a 40 mm diameter and 400 mm long copper test specimen. This is a specimen. And the fifth one is 40 mm diameter and 1 meter long GI pipe. And sixth one is a Fraser blower, and seventh one is a band heater of 250 watt capacity, and T1 is a air inlet temperature, T2 to T6 is the temperature of the specimen surface along the length. T7 is a air outlet temperature. So switch on the mains and set the dimmer stat at a some constant value, and leave it for some time until it comes to some equilibrium condition. Before switch oning the blower, note down the manometer reading. After that switch on the blower and maintain it to a constant speed, and note down the manometer reading. After that, note down voltmeter and ammeter reading and temperatures, that is T1, T2, T3, T4, T5, T6 and T7. Note down all the temperature reading. This is about the procedure, and repeat the experiment for different heat input flow rates. This is about heat transfer in forced convection procedure. And next, coming to calculation. So here T1 is the air inlet temperature, T2 to T6 is a specimen temperature, and T7 is the air outlet temperature. So note down the voltmeter reading and ammeter reading. V into I you will get. So after that, difference in manometer reading, HM. So after that, air temperature, that is air inlet and air outlet temperature, note down all the temperature, and the tube surface temperature, that is a T2, T3, T4, T5, T6. Note down all the readings. And coming to the calculation part, mass density, that is rho A, is by P divided by R into TR, that is in kg per meter cube. Here P is a temperature, atmospheric pressure, that is 101,325 Newton per meter square, and R is a gas constant of for air, that is 287 joule per kg Kelvin, and R is a room temperature, TR is a room temperature, that is in Kelvin. So pressure drop across the orifice, that is HA, is equals to rho m into HM divided by rho A. Rho m is the mass density of mercury, that is 13,600 kg per meter cube, and HM is a differential manometer reading of mercury. Okay, and next part is velocity of the air at the orifice. Okay, that is v naught is equals to cd into square root of 2g ha divided by 1 minus dc divided by d naught divided by dp raised to 4. Okay, that is in meter per second. Okay, v naught you will get. After that, velocity of the air in the tube. Okay, so that is a va is equals to v naught into pi d square divided by 4 divided by pi ds square divided by 4, that is equals to v naught into d naught the square divided by ds the square. So va you will get in terms of meter per second. Okay, and third one is the average surface temperature, that is ts is equals to t2 plus t3 plus t40 plus t5 plus t6 divided by 5 plus 273. So ts you will get in terms of Kelvin. So next part is mean temperature of air, that is T infinity. So T1 plus T7 divided by 2 plus 273. So you will get in terms of Kelvin, is the mean temperature. And after that, properties of air are taken mean, that is Ts plus T infinity divided by 2, which is in Kelvin. Okay. So at the temperature Tm, the kinematic viscosity mu and the Prandtl number Pr and the thermal conductivity K are taken from the properties of air table. Okay. So Reynolds number formula is Re is equals to Va into ds divided by mu, and Nusselt number formula is 0.023 Re raised to 0.8 and Pr raised to 0.3. So Nu is equals to H into ds divided by K. For a forced convective heat transfer, H is equals to Nu into K divided by ds. So you will get watt per meter square Kelvin. So rate of heat transfer, the formula is Q is equals to Ha into T infinity minus Ts. So Q is equals to H into pi ds into Ls into T infinity minus Ts. So Q you will get in terms of watt. Okay, this is about the experiment and calculation. Thank you.